Hi guys, sorry, my mom called me and it cut my video off, so I don't even know where I left off, and then I started to refilm, and then she called me again, so I already started, but here we go. So, example B. So, we have to write the equation of a sine function that has an amplitude of 4, a period of pi over 2, and a phase shift of -3. So, the phase shift -3 says that the graph should be going to the left 3, which means it probably was plus something in the actual equation, right? Okay, so let's go to our go-to get started formula. So, I'm going to use this formula to go and get me started, right? But remember, A could have been a positive or a negative number to end up having an amplitude of 4. So you have to keep in mind that there are two possible equations that this could have had if we're not looking at the actual graph, knowing if it went up like normal first or down first, causing the reflection. All right, so just give yourself a plus or minus. A times the sine of omega times x minus phi over omega, and then plus b. Now again, this one also does not talk about a vertical shift, so that means I don't need a plus b in my equation. If there's a vertical shift, you would just take that number and stick it on the back of your equation, okay? All right, so here we go. So we can start plugging in exactly what we know. So y equals plus or minus, well, what's a? Well, remember, if the amplitude is 4, then that's who you multiplied your amplitude of 1 by, so this represents your A. So if you're going to have an amplitude of 4, A must have been plus or minus 4. Times the sine of, now I need omega. Well, remember, in order to have a period of pi over 2, you would have found that by taking your period and dividing it, which was 2 pi, and dividing it by omega. So what did I, was that on screen? What did I divide 2 pi by in order to create a new period of pi over 2? So take your 2 pi over omega. What did you have to divide this by to end up with your period equaling pi over 2? So now cross multiply, and I get omega times pi equals 4 pi, divide by pi, and you find out that omega must have been 4. Okay, so now we can put 4 into our equation for omega, and then it'll be x subtract is the formula, phi over omega. Well, remember, phi over omega is your phase shift. So this is phi over omega. All right, so I can plug that in right now as x minus -3, and then it causes a superplus. That turns to plus, right? And then I don't need a plus b because there's no vertical shift. So this is your transformed function. We're going to clean it up by redistributing the 4. So y equals plus or minus 4 times the sine of 4x and then plus 12. And then there is your equation that would have all of these transformations happen to it. Now I said, if you wanted to use the original formula to get started, well then you'd have to solve for omega and you would need a phi. Once you know omega, right? Well, remember, your phase shift is phi over omega. And that means phi over omega would have to end up equaling -3. All right, we already know omega is 4, so you can put that in. Omega over 4 would have to end up equaling -3. Throw it over 1, and you can solve for phi. So you would get phi times 1 is phi equals 4 times -3, -12. So now you know who phi is, and you know who omega is. So if you wanted to, you could take this information and plug them right into the original formula, okay? And that would be y, I gotta get on screen, sorry. The original formula says y equals plus or minus a times the sine of omega x minus phi, right? That's the original formula, and then plus b, but I don't need it. So this would be y equals plus or minus 4 times the sine of omega, which is